Look around you. The universe isn't built on simple yes or no questions. Is it hot outside today? Your answer depends on where you've been, your comfort, your expectations. Reality rarely deals in absolutes. It's a spectrum, not a set of boxes. We try to force the world into ones and zeros, but reality spills over the edges. Consider the concept of tall. Is 6 feet tall? 5'11"? Where's the line? There isn't one. It's fuzzy. This fuzziness isn't a flaw, it's a feature of the cosmos. To navigate this world, we need a language that embraces uncertainty. Classical logic is great for clear boundaries, on or off, true or false. But life is full of dimmer switches, not just light switches. Judging ripeness, spiciness, or comfort. These are fuzzy problems. Fuzzy set theory, introduced by Lotfizadeh in 1965, is our mathematical dimmer switch. It lets us formalize common sense, translating vague language into something machines can use. With fuzzy sets, we can build smarter, more adaptable technologies for a world that's anything but black and white. Welcome to the fuzzy universe. Before we get fuzzy, let's visit the world of classical or crisp sets. Here, everything is absolute. An object is either in a set or it isn't. Imagine a box labeled even numbers. 4 is in, 7 is out. No debate, it's a digital world. Ones and zeros, in or out. This binary approach is powerful. It's the foundation of computers, engineering, and much of science. Think of a bouncer at a club. Your name's on the list, you're in. If not, you're out. No sort of allowed. This works for things that are naturally discrete. Planets, people in a room, items you can count. If someone's standing in the doorway, we just define inside more strictly, both feet over the threshold. Classical sets give us clarity and certainty, drawing sharp lines in the sand. But what about concepts like enjoyable movies or comfortable days? Your list and mine will differ. When we try to force these fuzzy ideas into crisp boxes, the model breaks down. The bouncer now has to decide who's cool enough, and the strict list is useless. The world of absolutes suddenly feels inadequate for the richness of human experience. That's where fuzzy sets come in. When the lines blur and certainty fades, not everything fits into yes or no. Sometimes the answer is sort of. Classical sets are great for what's clear-cut, but for everything else we need something more flexible. Enter fuzzy thinking. Now let's step into the world of fuzzy sets. Here, membership isn't all or nothing, it's a matter of degree. In a fuzzy set of tall people, someone 7 feet tall is a full member. 6 feet, maybe 90%, 5'10", 60%. The boundary is a gentle slope, not a cliff. This mirrors how we naturally think. Our confidence in calling someone tall grows with their height. Fuzzy sets replace yes-no with a scale, like swapping a light switch for a dimmer. Take ripe bananas. Green is out, brown and mushy is out, but in between, a yellow banana with brown spots might be 100% ripe, green-tipped maybe 70%, half-green 30%. This gradual membership lets systems, like smart fridges, understand the world with nuance. Fuzzy sets don't force reality into boxes, they flex to fit the vagueness of warm, fast, or close. By allowing partial truths, fuzzy theory gives us a way to reason about the uncertain and imprecise. The universe isn't black and white, it's painted in infinite shades of gray. Fuzzy sets help us model the world as we actually experience it. To use fuzzy sets, we need to speak their language, membership, and degrees of truth. A fuzzy set is defined by a membership function, a rule that assigns each item a value between 0 and 1. 0 means definitely not in the set, 1 means definitely in, and everything in between is partial membership. For warm temperatures, 50 degrees Fahrenheit might be 0, 90 degrees Fahrenheit is 1, 75 degrees Fahrenheit could be 0.8, very warm. 68 degrees Fahrenheit, maybe 0.3, somewhat warm. This is partial truth. A statement can be 80% true. For, close to home, 100 feet away might be 0.99, a mile away, 0.4, another country 0. This scale lets systems, like GPS, give smarter advice, distinguishing very close from somewhat close. By defining membership functions for concepts like low speed or high speed, we can create fuzzy rules. For example, if the car ahead is very close and my speed is high, then brake strongly. The system evaluates the degrees of membership and combines them for nuanced action. Fuzzy logic turns our intuitive linguistic understanding into computable instructions. It's how machines can reason with shades of gray. You probably use fuzzy logic every day, like in your washing machine. Old machines run the same cycle no matter what. Fuzzy logic machines are smarter. Sensors measure load size, fabric type, and dirtiness, not as yes, no, but as continuous values. The controller uses fuzzy sets: small load, medium load, very dirty, not very dirty. It doesn't make hard decisions. Instead, it combines partial truths from multiple fuzzy rules. For example, if the load is medium and water is moderately dirty, set wash time and water level to medium. The result? A cycle tailored to your laundry, just enough water, time, and energy. Your clothes get cleaner, you save resources, and you don't have to think about it. Fuzzy logic quietly makes everyday life better. Complex theory, simple results. Fuzzy set theory goes far beyond laundry. Self-driving cars use it to make sense of messy, real-world data. How close is the car ahead? How sharp is the curve? These aren't yes-no questions. Fuzzy logic translates vague inputs into precise actions. Braking gently, steering smoothly, driving like a human. In medicine, fuzzy expert systems help doctors weigh symptoms and test results that fall into gray areas. For example, if blood pressure is high, cholesterol is high, and chest pain is frequent, the risk of heart disease is very high. The system calculates degrees of risk, offering a data-driven second opinion. Fuzzy logic also powers industrial controls, financial analysis, and more. Wherever there's complexity and uncertainty, fuzzy thinking helps us manage it. It's the secret behind many technologies we take for granted. Fuzzy logic brings human-like reasoning to machines. It's how we teach computers to handle the real world. The universe is a place of gradients and ambiguity, not just black and white. Classical logic gave us the digital age, but it struggles with nuance. Fuzzy set theory doesn't replace classical logic, it extends it, bridging the gap between numbers and words. It lets machines understand instructions like make it a little warmer or drive more cautiously. This shift allows technology to partner with us, not just calculate for us. Fuzzy logic is everywhere, in your camera, your dishwasher, your car's brakes, and more. By embracing uncertainty, we unlock smarter, more adaptable systems. Lotfi-Zeti's mathematics of vagueness lets us compute with words and tackle problems once thought too fuzzy for math. The next time you face a question without a clear answer, remember the power of fuzzy thinking. The world's most powerful insights often lie in the infinite shades of gray.